I'm going to go through number 19, and if you checked on Aspen, just so that you know, it says not to do 19E, don't do this part. Okay, so a baseball is launched vertically upward from a height of 3.5 feet above the ground for Little League kids to practice catching. So I'm going to call the ground to be the 0 height, and we're going to have the baseball is going to get launched upward, and its initial height is going to be 3.5 feet above the 0, so that's y0, that's a given. And its initial velocity is upward, so positive 74 feet per second. And that's v initial. And that's what's given. And part A says, write the equation that models the vertical position of the ball as a function of time. So that's the equation that we did in class today. We said y of t is going to equal y0 plus v initial t plus 1/2 gt squared. Now, g is the acceleration due to gravity, and there's some notes on the class notes that I posted. But g depends on if you're in a problem that is using feet, then g is negative 32 feet per second squared. And if you're in a problem that's using meters, then g is negative 9.8 feet per second, meters per second squared. Sorry. So in this problem, we're using feet. We have feet and feet per second. So we're just going to rewrite this equation with the pieces that we know in it. That's going to be the answer to A. So I'll write this down below my problem here. Okay, this is the ground. We're going to write that the vertical height as a function of time is going to equal the initial height. Well, here's your initial height, 3.5, plus v initial t, right? Here's v initial t, but v initial is 74, so 74t, plus 1/2, since we're in feet, we need to use the g for feet, which is minus 32 t squared. So this is the answer to A. That is the equation that's going to model where the baseball is at any time. I could plug in any time, so I could plug in 1 second, I could plug in 2 seconds, and I would find where is the baseball at that time. Now, the next part of the question says, what is the maximum height of the ball? Well, here we go. These are the questions that we've been working on this week. Maximum height. Well, if I have an equation that is y versus t, I could graph this. So we're going to graph this projectile, this vertical pitch of the ball. And what's the x-axis going to be? Well, the x-axis is your time. How long do you watch a ball for? You know, maybe 4 or 5 seconds. So, you know, maybe go from 0 to 10. And then what about your y-max? Well, how high can a ball get thrown? So I don't know what it's going to be. I'm going to guess y-min is 0, and we'll go up to a y-max of 200. That's probably more than enough. 200 feet is a very, very high throw, but this is a pitching machine launched vertically. And when we plot this, you're going to get a graph that looks something like this. And what you're looking for part B is what is this max? So on your graphing calculator, you're going to do calc max. When you do a calc max on this, and you use your calculator, do second calc, and you find the max, you're going to get a point. And that point should come out to be 2.34. That's your x. And the y should be about 89. Now, this is your t, and this is your y, your x and your y, because your x-axis is t, and your y-axis is height. So that means that, what these numbers mean is that at 2.34 seconds, the ball was at 89 feet above the ground. That's the maximum on this graph, and that's the answers to part B and part C. It's going to go to 89 feet, and it's going to take 2.34 seconds to get to that point. Now, if the ball is caught at a height of 5 feet, so let's think about how to do this on our calculator. And we talked a little bit about this last week, but we have 3.5 feet is here. That's where this is starting. If I want to know when does this thing intersect the 5 foot here's the 5-foot mark on my y-axis. I could draw a line that's y equals 5. I could say y2 equals 5, and I could find that point there. I could find the intersection point of these two graphs. So I'm going to draw that a little bit bigger here. So we have our graph would look something like this. We know that this point up here was 2.3 and 89, a little bit more than 2.3. And that graph was our y equals 3.5 plus 74t minus 16t squared. That's what we had graphed. Now if we want to know when is this ball at the 5 feet line, we can graph a second line and say y equals 5. So the ball is going to travel up. It's going to go up, up, up along this path. And to get to the top, it's going to come down, 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 down. And y equals 5 is right here. So one way to do this is to do a calc intersection on this. Do a calc intersection point. That's one way to use your calculator on this. And if you do that, you're going to find that it's going to be at 5 feet at a point when t is equal to 4.6 seconds. Now, the other way to do this is to take our original function. So we know that y of t is equal to 3.5t plus is equal to 3.5 plus 74t minus 16t squared. And this question D, is saying, what is y? It's saying find y. How high is the ball? Oh, actually it's saying find t, find the time it takes to get y equal to 5. When the ball is at 5 feet, what is t? Well, look at this is what your equation is saying. When y is 5, so we're going to put in y, not the t, y is equal to 5 feet. Right? So if I was looking at my graph, here's the point, 5 feet. What's the x when y is 5? Well, I can plug y in for 5 and solve for my x value, my t value, right? I'm just looking for that ordered pair that's on this graph. So let's plug in. 5 equals 3.5 plus 74t minus 16t squared. If I had given this to you, not in a word problem, you would tell me that's a quadratic. We have to subtract 5 from both sides. And in order to solve this, we would say 0 equals negative 1.5 plus 74t minus 16t squared. Anytime we have 0 equals, that means that this is a quadratic equation, and I can either solve this by factoring, which most real-world problems don't factor very nicely. I could use the quadratic formula, x is equal to negative b, that formula, or I could graph this function. Now if I graph this function, I'm going to take this and I'm going to say, let's let y equal this. It's a slightly different function than before, and what happens is you get this graph. And here is the point from this function, that's the point when y is 0. And you will find that the t that makes this equation equal to 0 is 4.6 seconds. The same answer that we got by graphing the 5 line and finding the intersection. Either one of these is fine. You can take the y value, you can plug it in and solve for t, or you can say I want to find the intersection between my original function and the graph when y is 5, when the height is 5. Let's find that intersection point. That's 2 ways to do this problem, and number 20 is similar, and you can go ahead and try that one on your own.